Hi, this is a presentation of routing concepts, which is a part of my advanced networking course. Um, the routers are responsible for sending traffic from one network to another, and they do that by looking at the IP addresses or the layer 3 addresses, and by then figuring out where and how to send the information so that it will reach its destination finally. And they do so by looking into their routing table. If you look at the routers themselves, they're like a computer. They have, for instance, a CPU. They also have an operating system, and in Cisco devices, it's called iOS. And they also have memory and storage. They have RAM memory, they have ROM. They also have storage in, for instance, NVRAM, flash, and also in some cases a hard drive. Um, if you look at the different memory, we will see that, for instance, in the running configuration and the running operating system is always saved in the RAM. But then we also have the ROM, which has a small version of the operating system so that it can start up if it doesn't have any other operating system. It could also have it has some diagnostic software. The NVRAM is where we save our configuration files. So if we change the configuration and make something to the configuration, it will be saved and you can start it up on the same configuration again. And then we have the flash where we'll normally find our operating system, but also other system files. For instance, the VLAN DAT file in a switch, that is. Yeah, and apart from that, the routers have, of course, different interfaces depending on what we want to use them for. So they can have different types of interfaces, for instance, for fast Ethernet, for gigabit Ethernet, for other kinds of connections. If you want to have an internet connection, depending on what type you want there. So you typically have different interfaces for different purposes. And all of these interfaces are on their own separate networks. We can have an AUX port so that we could, if we like to do so, put in a modem, for instance. We typically have a console port because on many of the high-end routers, when you start them up, they're empty, so you need to configure them. And you cannot really reach them in any other way than connecting to the console port. They can have USB ports and so on. So they have different ports, and you can typically look at the backside, which is typically placed with the front out, so that you can see the different ports on your router. The routers will always try to choose the best path, and the way that what they think is the best path is different from whether you're using a RIP or OSPF or other kinds of routing protocols. But they will always try to find the best path, and that is what you will find inside your routing table. And when the router receives a packet with a certain IP address, it will look at the network part of the IP address and then look into its routing table and find out, do I know this route? Do I know this network, and where do I send it to get to the destination where I want it to? On the computers themselves, they also have the default gateway put in, which is typically the address of your router, because the router will then take care of the package and send it on to other networks. So when you configure your different devices on your network, you put in an IP address, a subnet mask, and then typically the address of the default gateway. So what happens then on the routers? Well, if you look at the OSI model and the different layers, the routers are layer 3 devices, which means that they will look into the package that they receive, they will unpack it up until layer 3, look at the address information, the IP address information, and then find out where to do and where to send it. And then they find out, for instance, I want to send it on to router 2. Router 2 do the same thing. Look into the layer 3 part and then find out where to send it. And if that is to layer or to router 3, it will send it onwards. So each packet or each router on its way will unpack up until layer 3 and then pack it in again and then send it on to the next hop router. And then at the end, it will reach the destination, which in this case is the PC2. So it will encapsulate and de-encapsulate up until layer 3, because they are layer 3 devices. If we have more than one path to the same route, or to the same network, well, then the routers will load balance, which means that they will switch between the equal paths to a network. Sometimes we have different types of routing protocols and different types of routing types running in the same network, and then we use the administrative distance. This is just a way of telling which routes are more trustworthy than others. And we will always choose the route with the lowest AD. So the lower the AD, the more trustworthy it is. And you can see that directly connected routes, the one that the router knows that it is directly connected to, has an administrative distance of 0, because that is the most trustworthy routes. And then we have the static one, the one that we configure ourselves, are also trustworthy. And we can see here that, for instance, OSPF has a trustworthiness or an administrative distance of 110, and EIGRP, which is the Cisco proprietary protocol, has a AD of 90. So it will choose a EIGRP route above a OSPF route, for instance. Yeah, so how do it populate? How does the router find out and put things into its routing table? Well, it does so by, for instance, first it will always look at its directly connected routes. And then it will try to figure out about the remote routes and find out how they are placed. And then we have the next hop associations, or the next hop routers. And if you look at it, it will always start by, of course, putting in its directly connected routes. And then depending on if you're running static routing or dynamic routing, it will start populating its routing table. We will look at, if you look at a router entry in a routing table, we will see where has it learned the information from. For instance, here, if it says a D in front of it, it means that this is learned by EIGRP. And we can see the destination network 10.11/24. 90 indicates the administrative distance, the trustworthiness of the route source. The 21 blah blah something is the metric. And it will always choose the route with the lowest metric. So this is because it's EIGRP. The metric is quite a large number. But that is the way it calculates the best path. And then it identifies the next hop. To be able to go to this route, I need to send the information to 219.165.200.226, and then it will know what to do with it, with the route or the packet. Then we have the time it has been in the routing table and which interface I want to send my information out on. This is the So mainly we can put in routes either statically, where we manually configure them. We use the IP route command and then say, if I want to reach to this network, I will go to that next hop route. Of course, also with the subnet mask. We have a default route which we put in if we want a default gateway. If we don't know a specific network, then it could be sent to the default network, and that indicates by 8 zeros. 4 zeros for the network address and 4 zeros for the subnet mask. This means then all networks. So if we don't know where to send it, we will send it to this address. That could be, for instance, if we have an internet connection and we don't know and we don't have a list of all the different networks on the internet in our routing table. So this is just to send it out to our internet router, for instance. Or we can have dynamic configured routers. That means that we will configure with some kind of a routing protocol, which means that the routers will then know and discuss with their neighbors and find out, okay, if my neighbor routers can reach 4 different networks, well then I can also reach them by sending them on to my neighbor. And so they exchange information about their directly connected networks, and they exchange information about their metrics. Of course, they need to have the same routing protocol configured. But this is, of course, the easiest way if you have large networks. You don't want to manually configure everything yourself, and then you can either use one of these, for instance, IGRP, which is the Cisco proprietary protocol. We have OSPF, which is an open standard. We had ISIS, which is not a good name anymore, but is also a standard routing protocol, or we can have RIP. RIP is a very old one, but simple one also. So that is the different types. Yeah, and we can actually have different routing protocols operating together, but we can always see that if we look at our networks and into our routing protocol, we can see how they have learned the different routes. Yeah, that was it. Thank you.